Our objective for this is solving equations. An equation is a mathematical statement that shows that two quantities are equal. To solve an equation, you must isolate the variable. To do this, you must do the opposite of whatever operation is being done to the variable term. For example, if I'm adding something to my variable, to solve, I will subtract. If I'm subtracting something from my variable, to solve, I will add. If I'm multiplying my variable by something, to solve, I will divide. And if I'm dividing my variable by something, then to solve, I will multiply. Here I have an equation involving addition. I have b plus 8 equals negative 4. To find out what I would have to add to 8 to get negative 4, I'm going to subtract 8. If I'm isolating my variable, subtracting 8 from 8 will leave me with 0. Now I only have b on the left side of my equation. But if I subtract 8 from the left side of my equation, I must also subtract 8 from the right side of my equation to keep things equal. Negative 4 minus 8 is negative 12. So my solution is b equals negative 12. To check, I can replace my variable with negative 12. Negative 12 plus 8 equals negative 4, so I know that my solution is correct. Here I have an equation involving subtraction. M minus 11 equals 16. To determine what I would have to subtract 11 from to get 16, I would add 11. If I add 11 to my term of negative 11, that gives me 0, leaving me with just m on the left side of my equation. If I add 11 to the left side of the equation, I also have to add 11 to the right side of the equation. I have to keep things equal. 16 plus 11 is 27, so my solution is m equals 27. Again, I can check. If I replace m with 27, I have 27 minus 11, which is equal to 16. So again, I know that my solution is correct. Here I have an equation involving multiplication. Because I am multiplying my variable by 4, to solve, I will divide by 4. Again, if I divide by 4 on the left side, I also must divide by 4 on the right side. Because 4 divided by 4 is 1, that would leave me with 1y. But because 1y is just y, I now have my variable isolated. Because 32 divided by 4 is 8, my solution is y equals 8. To check, I will plug 8 in for y. So I'll have 4 times 8, which does equal 32. So I know that my solution is correct. Here I have an equation involving division. Because I'm dividing my variable by 4, to solve, I can multiply my variable by 4. Again, if I multiply the left side by 4, I must also multiply the right side by 4. 4 divided by 4 is 1, and since 1x is just x, I now have my variable isolated. Because 13 times 4 is 52, my solution is x equals 52. I can check by replacing x with 52, and 52 divided by 4 is 13, so I know that my solution is correct. These were all examples of one-step equations. One operation was involved, and I took one step to solve. Now I want to take a look at a two-step equation. A two-step equation involves two operations. Here I have multiplication and I have addition. Because I'm using two operations in my equations, I will use two steps to solve. Again, I'm doing the opposite of whatever's being done to my variable term. Because my variable term right now is 5c, and I'm adding 7 to 5c, to isolate that variable term, I will subtract 7 so that I'm left with 5c. If I subtract 7 on the left side of my equation, I must also subtract 7 on the right side of my equation. And 22 minus 7 is 15. Now, I'm back to a one-step equation where only one operation is involved. 5 times c equals 15. So now I'm multiplying my variable term by 5, and to solve, I will divide each side of my equation by 5. 5 divided by 5 is 1, and 1c is just c. 15 divided by 5 is 3, so my solution is c equals 3. Again, I'm going to check my solution to make sure that it is correct. My original equation was 5 times c, but now that I'm saying c is 3, I will have 5 times 3 plus 7 equals 22. Because 5 times 3 is 15, and 15 plus 7 is 22, I know that my solution is correct. Here I have another two-step equation where two operations are involved. Again, I have multiplication, and this time I have subtraction. So I'm going to do the opposite of whatever's being done to my variable term. Negative 2y is my variable term, and I'm subtracting 14 from that. So to solve, I will add 14 to each side of my equation. Because negative 14 plus 14 is 0, on the left side of my equation, I'm now left with negative 2w. Negative 26 plus 14 is negative 12. So now I'm back to a one-step equation. Negative 2 times w equals negative 12. Because I'm multiplying my variable term by negative 2, to solve, I will divide each side of my equation by negative 2. Negative 2 divided by negative 2 is 1, and 1w is just w. Negative 12 divided by negative 2 is positive 6, so my solution is w equals 6. Again, I will check. Negative 2 times w, which I'm saying is 6, minus 14 must equal negative 26 if my solution is correct. Negative 2 times 6 is negative 12, and negative 12 minus 14 is negative 26. So again, I know that my solution is correct. Here, I have another two-step equation. This time, I have operations of division and subtraction. I'm going to isolate my variable term, which is h divided by 2, and I'm going to isolate that by adding 9 to each side of my equation. Because negative 9 plus 9 is 0, I'm now left with h divided by 2. Because negative 12 plus 9 is negative 3, I now have a one-step equation. H divided by 2 equals negative 3. Now I'm dividing my variable by 2, so to solve, I will multiply each side of my equation by 2. Two divided by 2 is 1, and 1h is just h. Negative 3 times 2 is negative 6, so my solution is h equals negative 6. Again, we're going to check our solution by replacing h with negative 6. Negative 6 divided by 2 minus 9 must equal negative 12 if my solution is correct. Negative 6 divided by 2 is negative 3, and negative 3 minus 9 is equal to negative 12. Here I have the equation negative 4 times 2x plus 5 equals 12. I have it written twice because I'm going to show you two ways to solve. I know that when I have a number beside a set of parentheses, I can use the distributive property and multiply each number in the parentheses by the number that's outside the parentheses. So here I can multiply negative 4 by 2x, and I can multiply negative 4 by 5. Because negative 4 times 2x is negative 8x, and negative 4 times 5 is negative 20, I now have the equation negative 8x minus 20 equals 12. So I now have a two-step equation, and I can isolate my variable term by adding 20 to each side of my equation. Adding 20 to negative 20 leaves me with 0, so I have negative 8x left on the left side of my equation. 12 plus 20 is 32, so now I'm left with a one-step equation, negative 8x equals 32. I'm multiplying my variable by negative 8, so to solve, I will divide each side of my equation by negative 8. Negative 8 divided by negative 8 is 1, and 1x is just x. 32 divided by negative 8 is negative 4, so my solution is x equals negative 4. When I check, I will replace x into my original equation with negative 4. Negative 4 times 2 times negative 4 plus 5 equals negative 12. If I use the order of operations and work within parentheses first, I have 2 times negative 4, which is negative 8, plus 5, which is negative 3. So I have negative 4 times negative 3, which does equal which does not equal negative 12. It equals positive 12. Which means we got a step wrong somewhere. We don't want it to equal negative 12. We want it to equal positive 12. So our solution is correct. The second way I'm going to show you is because I'm multiplying all of this by negative 4, I can go ahead and undo that by dividing all of that by negative 4. If I divide the left side of my equation by negative 4 and divide the right side of my equation by negative 4, negative 4 divided by negative 4 is 1, and 1 times 2x plus 5 is just 2x plus 5. 12 divided by negative 4 is negative 3. Now I'm left with the two-step equation, 2x plus 5 equals negative 3. I'm adding 5 to my variable term, so to solve I will subtract 5 from each side of my equation. Positive 5 minus 5 is 0, so I'm left with 2x on the left side of my equation. Negative 3 minus 5 is negative 8, so now I'm down to a one-step equation of 2x equals negative 8. I'm multiplying my variable term by 2. So to solve, I will divide both sides of my equation by 2. 2 divided by 2 is 1, and 1x is just x. Negative 8 divided by 2 is negative 4, and I get the same solution as I had when I distributed the negative 4 first, as I did if I divided by negative 4 first.